offline, I made a little bit of progress. So I re-implemented the paragraph splitting logic in JavaScript, and I was able to use some existing natural language NLP libraries for that. So now I have this library that's just going to ingest an HTML document, perform a bunch of transformations on it, and save the resulting HTML. And so that is, I think, all I need to get out of JavaScript. And so hopefully I can just pretend that never happened and forget about everything in the JavaScript world. And I think that the way that I'm supposed to build containers in Bazel these days is rules OCI. So I figured today I would try to figure out if I can get rules OCI to work with these kind of weird languages that aren't super Bazel supported yet, namely Haskell and JavaScript. Okay, and so there's a bunch of examples. I guess C++ might be the right kind of level of abstraction. So it looks like I have this package tar thing that's going to tar up my whatever, I guess, the Bazel build as a binary. And then I have this OCI image rule, which I'm going to point it to some base container. In this case, it says @dockerlib Ubuntu. That's presumably a link to this docker.io/library/Ubuntu, but I'm not sure where it's defined. Here, this goes in modules, module.bazel. We're going to call, we have this OCI.pool. So we're going to pool the image, what image, this image, and we're going to give it this name, which is what we referenced here. I don't know why it has an @ sign. I guess that means it's a, I thought workspaces had @ signs, but I'm not sure if this is like implemented as a Bazel workspace or if it's own thing. And then we have this, well, yeah, here we go, use repo. And we're calling use repo with OCI and passing in, I guess, I don't know what this first argument is doing, but presumably telling it something about OCI. And then this is, I guess, the name of the repo. And we have to import rules package. And then we call Bazel run image load, which will load the image. And then we'll call, and then it's available, I guess, in the Docker system. So let's try it. Why don't we grab this whole thing? Actually, let's grab the stuff that needs to go into the modules first. Oh wait, I'm not using modules in this file. Can I go in workspace? Let's try this again. I'm going to click the copy button. I'm going to paste it. There we go. Okay. So what is this Bazel dep thing? Bazel dep might only work in module.bazel. Okay, so let's try again to see if this works. So this I'm expecting not to work because I'm not sure that Bazel dep is a thing that exists in workspace. Yeah. So what if I look for So we do have a workspace here, but that may not be indicative of anything. In the workspace, it seems like we don't use the use repo, and I don't know what this other thing was. So let's just delete it. Basil dep. And let's grab one of the workspace things. We're going to call this load file a single Arch based. Arch is in what? Architecture or Arch Linux? Oh, I think it means Arch is in architecture. Let's grab this. I don't want to use distroless Java. Okay, so what's different here? So we have platforms. That's fine. Tag rolling. Are we tagging that? I don't know if we are tagging that. Or is that the existing tag? It looks like rolling is a tag from Ubuntu. As we suspected. I don't think it's wise to have a rolling release tag. So I'll see if I can do 2404. And then I need to actually pull in this container somewhere. Or rather, consume it. So let's grab this. Okay, so let's add it here. Okay, so we don't need this example binary thing. We will do package tar. The sources will be, the thing they pass to sources is the binary. So we'll pass in the server. I'm guessing that so this won't work for a variety of reasons, one of which is that I think the default Ubuntu doesn't have what Haskell needs for runtime. I made a bit of progress offline. I finished the rules OCI configuration, which I think is what I was working on last time. Last time I did a video. I guess I'm moving to sort of a devlog role where a devlog format where I'm recording some of these videos offline and posting them and kind of just summarizing some of the progress I've made, because it's too hard to try to make all of the progress on screen and it's taking too long. But I'm not sure if I showed this, but I upgraded to Ubuntu Noble. I might have been using Debian when I stopped filming. I was running into problems where an old version of glibc was causing errors, and all of my machines are running a version of a Debian-based distribution that has a newer version of glibc, and that was just upgrading everything, upgrading the container just made that transition nicer. I still have a problem, which is what I'm going to try to tackle today, which is that the reason that so many of my dependencies are old is because gRPC Haskell uses a really old version of gRPC. So if we go to the gRPC Haskell repo, this was updated within the year, but it's using gRPC version 1.45.0, which I think is maybe about 2 years old. February 2022. So it was 2 years old this February. So maybe almost 3 years old. And that's old. And one of the reasons that's a problem is because gRPC, like all of the Google libraries, really wants you to live at head. And Bazel wants you to live at head, and protocol buffers wants you to live at head. And so when you're using a gRPC that's this old, then you run into problems where you can't compile it with a recent version of the compiler. Like for a while, I had to compile with GCC 12, which was a bit of a chore getting a GCC version that old on some of the operating systems. And similarly, the version of protocol buffers and abseil to Google libraries that gRPC uses, there were versions that were sufficiently old that they couldn't compile on GCC 13, and Bazel wouldn't work with something that's old because of how the Bazel rules have changed over time. And gRPC itself doesn't yet support newer Bazel stuff like Bazel modules. So gRPC itself is already kind of jumping through some hoops to use some older libraries. And so all of that was a mess. So I spent some time yesterday starting to fix much of that up. And it doesn't look like much, but basically I have a simple Bazel module file, which has relatively old dependencies. Like I'm using gRPC 1.47 instead of 1.43, which is what I think I was using as of a couple of days ago. And I think I can probably make 1.47 work, even though gRPC Haskell says they don't support anything above 1.45. The main difference I'm running into is that around 1.45-ish, gRPC dropped support for the old way of doing insecure channels. And so their API changed. And since gRPC Haskell is wrapping the API, that causes a change in gRPC Haskell. Now it looks like gRPC Haskell supports that API change. And so what I want to do today is just see if I can finish up this updating spree by upgrading gRPC Haskell. I do have a bunch of changes. Well, maybe not a bunch, but I do have several changes to gRPC Haskell that kind of fixed bugs that I was facing. So I have to merge their changes with my changes. That might be interesting. That might be hard. That might be easy. I'm not sure. But so that's what we'll do. And here we go. gRPC 1.45 plus support. And I think somewhere adjust to the removal of insecure build. I think that this is the thing that I'm looking for. Okay. So that's what we're doing. So I just grabbed the most recent gRPC Haskell. I'm not sure the right way to do this. I guess what I'll do is I'll just copy this over to where my current one is located and resolve the differences. Didn't I get ignore this node stuff? Okay, so I'll rsync it. Why is it skipping there? There we go. Okay. So now let's see what this looks like. There are changes to .github. That's an untracked file. Did I copy it into the right folder? This is the thing that I always struggle with rsync, is whether to leave the trailing slash or not. Yeah, I got that wrong. How do I get rid of untracked files? Pass a bunch of stuff to it. I can reset hard. Is N like dry run? Let's try that. What is N? N is dry run, and D is remove untracked directories in addition to untracked files. Oh yeah, let's try that. Okay, and so hopefully everything it removed is something I wanted it to remove. Let's try rsync again. And this time we want the whole directory moved over instead of the contents of the directory. So we omit the trailing slash. And that looks more promising. Now we have a bunch of changes and we don't need all of them. I guess we could incorporate the README. Do I care about their .github file? Oh, it's a whole directory. Ooh, yeah. I think that what Maggot is doing is it's seeing that it's in another repo. Let's get rid of the Git repo there. And if we go into .github, we just have this workflows and CI stuff. I don't need that. But I'm a little bit confused about why we have this this why maggot is going to another directory. So let's try this again. This looks better. I don't think I need any of that ignore stuff. What does D do? D is do what I mean. Diff. Bench has some changes. And if I go into bench, I back into another Git repo. Maybe the Git repo is in third party. Yeah, that's the problem for my failed attempt to rsync it. Okay, so bench is untracked. I don't know why it's untracked. Maybe I couldn't get it to build. So I just deleted it. Bench and bin. This is some bash file for installing gRPC on Mac. So I don't need that either. I don't need the cabal file. Do I need core/include? Seems like I do. How is that not tracked? Maybe it's not tracked because I moved it. I don't need shell.nix. Maybe this wasn't the right thing to do. Let's try this. Let's reset hard. And then let's do a diff between these directories. Maybe meld. And in fact, I think I want it to go the other way. Can I swap them? Okay, so this is much better. Now I see what I don't have here. I'm sure I could do this in Emacs, but I think meld is easier to deal with. So I'm guessing that maybe I don't know what blue means. Green seems to mean that it's something that doesn't exist on the left, but does exist on the right. I'm guessing that blue maybe means that there are changes. That's a change I remember. Now, how do I back out of this? Oops. Okay. So I deleted a bunch of stuff. I deleted the tests. I think that vaguely rings a bell. That was because they didn't really work, at least not with my setup. I don't think I could get them to work with Nix either reliably. There's a bunch of Nix stuff here that I don't need. Some examples like Echo that is using like custom C compilation. I don't need any of that. That's going to make the build more complicated. I don't know if that even has changed since the last commit. In fact, we can also visualize things like this. Um, we can look at what's changed. Can I make this dark? It's a bit blinding. So most of the stuff hasn't changed. There's a memory leak that's fixed here that changes the C file and a Haskell file. And here they're using gRPC 1.42. This is from 2023. I don't know when the version I copied is from. So the version I copied used 1.42. I think I kind of upgraded it to use 1.43. But that at least gives me a bound on how new it was. Some of these are changed. I don't know how many of these have been changed from to support the change in the gRPC API versus other work. The README has changed. The license looks like it's the same. There's some configuration for things like Formolu. The is it linting or I think it's code formatting, right? But I don't think that I don't think that I have that working yet. I mean, maybe it's worth doing. And so I made changes to arithmetic and the client and the server and stuff to get them to build. But what I was originally opening meld for is I was curious why the include file was untracked when I copied it. And I think it's because I removed it. It seems to be the case here. I moved it from include /grbc underscore haskell.h to somewhere else. And let's see if we can find it on the right. It should be something that's crossed out here. Okay, I moved it to co-locate it with the C file, which is the style I prefer. So that's fine to do. These two things are probably differ. Let's see if I can compare. I can highlight one. Can I highlight the other? I think this is just comparing one file to itself. So I can't shift click or anything, but I can mark them both. I don't know what marking does. Okay. So it looks like the header hasn't changed at all, which is maybe a little bit strange because I thought that this had things like insecure server. Or maybe not. Maybe that's in the C2HS file. So I think I'll just go through these diffs and apply as needed. If there's a change that seems relevant, I'll apply it. If it seems irrelevant, I'll consider ignoring it. And I'll probably do that all off screen because it'll be relatively boring. Okay, so I don't exactly remember where I left off, but I now have two working Docker containers, one running the Haskell gRPC service and one just running Node. And I want to get rid of JavaScript as much as possible. I want to imagine that it doesn't exist. And I think that the way that I've decided to do that is that instead of putting the Node and JavaScript code in the same container as the Haskell server and having the Haskell server call Node using the shell, instead of putting, as I was just saying, instead of putting Haskell and the JavaScript in the same container, I'm going to put JavaScript in its own container and run it periodically. I'll probably have Haskell kick off jobs to run the Node container to perform readability cleanup. And I may use cloud events for that. I'll probably have the Node container talk to the job queue database that I built, because I do want to have some sort of locking. I don't want two runs of the Node container to modify the same directory simultaneously. I think I probably don't really have to worry about that for the time being, but it will eventually happen and I don't want it to cause trouble. So I'll have the Node container try to grab some sort of lock on the database job and only read data from directories corresponding to jobs it's locked. So I need to build that. I think that'll be relatively simple. I'm trying not to add any new dependencies to JavaScript because the Bazel support for JavaScript is pretty precarious. And I'm using the old stuff, which is relatively simple and pretty Bazel-y, but pretty precarious. And then there's some new stuff that's not very Bazel-y, in my opinion, and is more featureful. And I want to try to avoid if I can. Hopefully I can cut out JavaScript altogether before I need anything semi-complicated. So that's the goal. And that sort of architecture, I think, will be generalizable to other sorts of resources we want to add, like PDFs. There will have to be some code that reads the PDF and converts it to text. That's possibly something that Pandoc can do. I'll have to look into Pandoc. But that would be, for example, another container running a different job, and locking would work more or less exactly the same. So here's the task queue as it exists. We have a job ID, which I think I'll use the job ID as it will appear in the folder hierarchy so that the script knows which folders to go into. And there's also this job proto. It may be that I think the proto has things like the title. So the proto just has the job ID and the URL that we're trying to archive and the status. This is for communicating between the back end and the front end and the database. I guess that it's probably the case that that the JavaScript doesn't need to understand protos. I'd rather not have to add proto support for JavaScript, essentially for the complexity reasons I just mentioned. So if the folder format has the ID, then all I need to do is take a list of IDs that I've locked and pass them to the JavaScript function. Right now, the JavaScript function takes in an output directory and a bunch of files. And so it's going to take, let's see. I think I want to modify this so that instead of taking a bunch of files, individual files, I want it to take in a list of input directories, which will be the job IDs. And it will it'll grab all of the files in that directory and write them to the output directory with the same job ID path. And so I need to do that. So let's start I should write a doc for this, but I don't really have a place for docs, and I'm not keeping the docs up to date. So perhaps what I'll do is I'll start just documenting the design in this Git commit until I have something like a bug tracking system set up. Okay. So we'll call this job queue integration for JavaScript. And we'll say this is a design overview. So the node service runs on a container periodically and can also be kicked off by a cloud event trigger. I guess being kicked off by a trigger is probably sufficient. Although I guess we can have it kicked off and then perhaps the Haskell service can monitor whether it needs to be kicked off. Well, I don't know. We'll say both, and we can modify it later. Okay, so it's going to be kicked off periodically. On start, it grabs a list. It grabs database rows. So on start, it grabs and locks database rows that are ready for processing, and it uses the job ID as the folder, and processes jobs in each job folder, writing to output directory. So this is the node service, and then this is the Haskell service. So the Haskell service on so receiving an RPC to save an article, it uses wget to so it first of all, it creates a job in the database in the job queue. B, it uses wget to fetch the article and updates the job queue with the result. And C, if fetch was successful, it updates the job queue to indicate it's ready for readability processing. If any jobs are ready for readability processing, sends a cloud event to the node service to start readability processing. And then I guess the last thing it does is it checks if any jobs have finished, successfully finished readability processing. We will mark the job queue as done and notify the client as needed. All right, so that's the basic gist. So given that gist, there's a few things I have to do. So I guess we're doing this. Might as well keep doing it. So to do is update vector backend JS main.js to take job IDs as directories instead of requiring the HTML file. Another thing we have to do is update the job queue to be able to articulate a job status that so to be able to articulate that a job needs further processing, e.g. readability for HTML, OCR, or text conversion for PDF. We'll need to update the Haskell statements to understand the new job queue changes. I don't know if I can treat this as an org mode buffer, can I? No, that's fine. We'll need to update the job proto to reflect any changes. I think it's mainly client visible changes and update. You'll need to manually regenerate any Haskell code that uses Proto 3 Suite. And that's the main gist. I guess we'll try to put this in a documentation folder somewhere. Okay, so now that works. I think this is mainly the overall stuff. I need to make a decision about how to how to do what. So I guess I'll write down the decisions. So make a decision about so I'll need to decide the right way to encode the next change, because I want it to be extensible, but I also don't want the services to have to think too much about whether they are actually needed. So decide how to encode the needed next step in the job queue database. So that's one. And to decide on how to end-to-end test. I guess we'll call them integration tests / end-to-end tests. And those are the two main ones. I'm thinking that for the job queue, or task queue, we have pending, completed, and failed. I could have something like waiting. I'm going to add needs processing. And I'm going to add it in the middle because I don't have any real data yet. and I will add like a stringy thing. Varchar. I think that maybe what I want is kind of like a tag, because I guess I'll just assume that everything just needs one kind of processing. I can't see right now needing both, and I don't want to generalize too much. So how about we do processing type is, we'll call it HTML readability, and then PDF are the two types. So obviously it can be nullable. We'll say the default is the string HTML readability as processing type, and that's possibly valid valid SQL. And I think that that's probably enough. So then the Haskell Haskell, once a W gets something, it will mark it as needing more processing. And then when it's done, the JavaScript will mark it, the processing is done. I could maybe just, instead of doing this enum, I could have a Boolean that just says, do we need processing? And if it's true, then the JavaScript code will grab a lock on that row. But I think I want to differentiate between things that never need processing and things that need processing but have finished successfully. And I can't do that with just a Boolean. But that does suggest that maybe I should add another type here that says processing complete, so that Haskell knows that the node code is finished. I think that's basically it. So just a quick run through of some of the changes that I've made. I think the last time I recorded an update, I had designed the job queue, how the JavaScript is going to interact with the job queue. This change here to separate out this process file function, that's just a midterm refactoring to make the rest easier. And then I updated the job queue. I migrated to the new Bazel rules for JavaScript, which was not as painful as I was concerned. There's still a little bit of like cruft there, where for a lot of the Bazel rules outside of Google, seems like the organizations that make them are trying to turn Bazel into they're trying to add value to Bazel by making it appealing to people who already really like the build systems that they're currently used to. And so there are a bunch of touch points with the current build systems that I would consider to be leaky abstractions. So instead of having the Bazel interface to everything, there's you need to create standard JavaScript configuration files, or JavaScript unit test configuration files, or Python requirements files. In my opinion, there should be a minimum of all of that, and you shouldn't even have to know what the underlying implementation is. And everything should be done in the Bazel build rules, so that you don't have to know every library's ecosystem in order to use the build system. That's one of the ideas of Bazel. But for whatever reason, I'm guessing because that's just a hard goal to achieve, it also doesn't seem to be a design requirement for a lot of these public rules. And in my opinion, that's one of the things that's holding Bazel back outside of Google, is because the experience really depends on your familiarity with the existing packaging and build systems of the individual languages, which frankly are usually pretty terrible compared to what Bazel is capable of. So they kind of leak the implementation details. It's not that bad for what I'm using of rules.js, but I do have to make decisions about which features to use based on kind of not wanting to have too many dependencies on the JavaScript ecosystem. Because frankly, that might all change. We may switch out Node for Dino or something like that, and that should have basically no visibility into the files that are on my are in my repo, other than changing a few words in the build files. In my opinion, that's the ideal, at least. But anyway, that rant aside, I just made a couple of changes to SQL. I may have shown this. We just added a new type for what kind of processing we're doing, and we're just recording whether we need to keep processing or we're done. A lot of it, so this npm link all packages is also really weird. I think that this is maybe something that they talk about in their documentation, the way that they've worked around limitations in npm. I think the right thing to do is to fork or patch npm to not have those limitations. And I'm guessing that might be what they do internally at Google, although I've never used JavaScript rules internally at Google. But you can understand why rules authors may not want to maintain a patch of npm. And then we also have this lock file, which again is a thing that only the JavaScript tools care about. It would be nice not to have it, since the dependencies are already in the modules, the module config, the workspace config, the build file config. So essentially it's redundant information. I guess that one of the purposes of the lock file is to have exactly which version of which dependency is needed. That in theory should be part of the module system or in the workspace file. But I think as a convenience, they use the standard JavaScript lock file. And the Python rules also do the same thing, which I think are written by Google. Anyway, and then we had to configure some modules, etc. And this is more like lock file nonsense. Okay, so mostly that wasn't so bad. It wasn't great. I'd like to see the ecosystem move away from that sort of approach, but that's neither here nor there. And then there's just an initial task queue implementation. And most of it is just here. We're going to grab some rows where the statuses need processing. We'll say that we're going to update them, which will lock the rows for update. And then we're going to skip the rows that are already locked. And then for each of the rows, we're going to call process job ID, which is going to call the process folder function, which was the original function that I wrote to apply the transformations like readability, etc. And that's all this is going to do. And so now this is going to go into a container. It's going to wake up periodically, probably in response to like a signal, like a cloud event. And then it will process everything that needs processing and then signal that it's done. And I'm probably going to use Tekton for that since I already have Tekton set up for that. I'm sure you could use all sorts of other pipelining tools. You could probably use the Kubernetes serverless thing. I think Knative is what it's called. But since I already have a tool set up that does triggers and runs jobs, I'll try that. Another option is to run it as a cron job. Another option is just to have it as a service that you can send an RPC or a REST call to and have it respond to that. But we'll try Tekton, see how it goes, and I'll update when that's done.